All right, guys, let's do this practice test. 14, last one before Christmas. That's awesome. Here we go. Make sure you got your sheet with you. And one thing you should find on your identity page or your formula page are the formulas for sine 2 theta, cosine 2 theta, and tangent 2 theta. And they're located on the back, I believe. Actually, yeah, on the back of your identity page. You should see those. And that's what I'm going to use here. So the first one says sine 2 theta. Oh, before you do this, you need to find the cosine. You got to have sine and cosine to do these. So I'm going to find the cosine. And remember, if it's 5 something 13, it's 5 12 13. So cosine is 12 13ths. And it's positive because we're in quadrant 1. Okay, so here I go. Sine 2x. I'm going to do 2x instead of theta. The formula is 2 times cosine theta sine theta. So I'm going to do 2 times 12 13ths times 5 13ths. And just multiply that out. And you would get, let's see, 120 over 169. Then when I do cosine 2x or 2 theta, you have 3 options of what to use there. I'm going to do the one that says cosine squared minus sine squared. If I do cosine squared, which is 12 13ths, that's 144 over 169, minus sine squared, which is 25 over 169, and that's going to equal 119 over 169. And then the good news is once you get the tangent 2x, there's no need to do that formula. Remember, tangent sine over cosine. So I'm going to take the sine and the cosine and put one over the other. The 169s cancel. You just get 120 over 119. I'm going to do the same thing here for the second one. Second one says cosine is negative 4/5, and it's in quadrant 3. You got to find sine first. If cosine is 4/5, remember the triangle is a 3, 4, 5, so it's going to be 3/5. And because it's quadrant 3, sine and cosine are both negative in quadrant 3. And now I'm going to do the same thing I just did. Sine 2x is 2 times sine theta times cosine theta, which is that right there. So multiply that out. 12 times 2 is 24 25ths. Cosine 2x, I'm going to do the same thing again. Cosine squared minus sine squared. Cosine squared would be 16 25ths. That's 4/5 squared. Then I'm going to square to 3/5, make it 9 25ths. So do my subtraction there, 7 25ths. And then again, tangent 2x. I'm not going to do the formula. I'm just going to put the sine over the cosine. The 25s cancel, 24 sevenths. And that's it. That's all you got to do. All right, number 3, use the half angle. The half angle formulas are on your identity page on the back. This one says cosine 67.5. What we're going to do, it's half. That's half of an angle that we know. So what I'm going to do is I'm going to double 67.5, which would give me 135 over 2, because 135 over 2 is 67.5. So I'm going to use the cosine x over 2 identity, which is on our formulas on the back of your paper. I'm doing plus or minus 1 plus cosine x, x being 135 degrees over 2. The one thing you do have to know, well, first of all, let's do this. Cosine 67.5. 67.5 is in quadrant 1, so that means it's going to be positive. So I'm going to drop that plus or minus and just know it's positive. Also, cosine 135, everybody knows that's negative square root of 2 over 2 because it's 45 degrees away from 180 in quadrant 2. Now, we got to simplify that. Remember how we did that? We multiplied the whole top and the whole bottom by 2. When you do that, you get 2 minus the square root of 2 in your numerator. The denominator is just 4. And I would be done, except I know the square root of 4 on the bottom. So I'm going to leave the square root on the top like that. The bottom, I'm going to take the square root of 4, which is just 2. And that's where you should end up right there. Pretty good problem. All right, number 4 and 5. Find an equivalent expression for each of the following. Cosecant. Remember what cosecant is? Cosecant is reciprocal of sine. So I'm going to do this. I'm going to do 1 over sine of x plus pi over 2. So what I'm going to do now is I'm going to look at my identity page for the sine of x plus y. All right, and I'm going to do that down here. I'm going to say sine of x plus y is sine x cosine y, which is pi over 2, plus cosine x sine pi over 2. Now here's what you do have to know. Cosine of pi over 2 is 0, which is going to take this whole term right here is a 0. That's gone. Sine pi over 2 is 1. So I'm going to do 1 times cosine, which is cosine. So I get this. I get 1 over cosine x. And guys, everybody knows 1 over cosine x is really just secant x. So that's what you get for number 4. Let's go 5. Number 5, cotangent x minus pi over 2. So I'm going to go with 1 over tangent of x minus pi over 2, which is what that is. And I'm looking at my formula page for tangent x minus y, and it says tangent x minus tangent y over 1 plus, it says tan minus tan over 1 plus tan tan. So I'm going to flip that. I'm just going to flip it. I shouldn't have even written that. I'm just going to flip it to do cotangent and do 1 plus tan tan over tan minus tan. So it's going to look like 1 plus tangent x tangent pi over 2 over tangent x minus tangent pi over 2. Now, the weird thing is tangent pi over 2 is undefined, which takes that away and that away, which just leaves me 1 over tangent x. And, of course, 1 over tangent x is cotangent x, which is kind of strange when you think about it. Okay, let's keep going. Number 6 just says simplify. Okay, now, don't forget, if you have a square outside of a parentheses, that square does not, remember, you got a square, multiply double square. So I'm going to square the sine. I'm going to multiply the sine x and cosine x together and double it, which means you put a 2 in the front. And then I'm going to square the cosine, which gives me cosine squared. And here's what I notice. I got a cosine squared and a sine squared. That's 1. Sine squared plus cosine squared is 1. So it gives me 1 plus 2 sine x cosine x. And guys, that's as simple as you can get it. You can stop right there. Don't make it harder than it is. Let's go to number 7. Number 7 says factor and simplify. That's a difference of squares right here, even though it's the 4th power because they're even. It's difference of squares. So I'm going to say that's sine squared x plus cosine squared x times sine squared x minus cosine squared x. Now, here it is again. There's the sine squared x plus cosine squared x, which is 1. So it's really 1 times that, which is itself. So my final answer is sine squared minus cosine squared. Now, that looks kind of weird, and you kind of want to go further, but what you got to remember is it's sine squared plus cosine squared is 1, not sine squared minus cosine squared. All right, let's hit up number 8 here. Number 8 says simplify. What I'm going to do is I'm going to factor the numerator. It looks like, I'm going to think about what factors of 1 would give you 2. And the answer is 1 and 1. So instead of doing like, or if this helps you, you can think about it like this. You can think about that being x squared plus 2x plus 1. Except your x's are really sines. Okay, so when I factor that, it'd be x plus 1, x plus 1. But instead of putting x, I'm going to put sine x plus 1, sine x plus 1 over sine x plus 1. All right, when you do that, these just cancel. It just leaves you sine x plus 1. That's as far as you can go. Not too bad, really. Number 9, use the sum of difference identities to evaluate cosine 15. So what you got to do is you got to find some way to get 15 degrees out of 30, 45, and 60 degrees. Those are our big 3 right there. So I think it's 45 minus 30. So I'm going to do cosine of 45 degrees minus 30 degrees. And all I'm going to do is I'm going to find my cosine x minus y, and let the 45 be my x and my 30 be my y, and just work it out. So I'm going to get cosine 45, cosine 30, plus sine 45, sine 30. All right, now those are values you're supposed to know. Cosine 45, always square root of 2 over 2. Cosine 30, always square root of 3 over 2. Sine 45, square root of 2 over 2. Sine 30, always a half. So what that gives me is square root of 6 and a square root of 2. And both fractions have 2 times 2 on the bottom, which is just 4. And remember, we got that answer a whole lot the other day. Quite a bit. All right, number 10. 10 says cosine 83, cosine 53, sine. So the pattern is this. The pattern is it's going cosine, cosine plus sine, sine. So I'm looking at my cosine addition and subtraction to figure out which one that is. And the one that says cosine, cosine plus sine, sine is actually cosine x minus y. So I'm going to do this. I'm doing cosine x minus y, where the 83 is my x and my 53 is my y. So if I do cosine 83 minus 53, it gives me cosine of 30 degrees. And you can stop right there if you don't know what cosine 30, I mean, if it's a number we don't know, but we do know what cosine 30 degrees is. It's square root of 3 over 2. And there you go. All right, let's do the back. All right, here we go. The part, that we did yesterday, yesterday that was so much fun. It says prove identity. So what I've got to do is I've got to make this left-hand side be cosine. Okay, so let's just go out. The best thing, remember, don't sit and stare. Don't sit and stare. All right, so change everything to sines and cosines. Secant is 1 over cosine. Sine is sine. And tangent is sine over cosine. All right, so got that far. Now, always, once you do that, do the math. Okay, what I see is I see a subtraction and a multiplication. You got to multiply first. So if I multiply sine x times sine x cosine x, I get sine squared over cosine x. Notice the denominators are the same. So because of that, I can make it one big fraction and put the 1 minus sine. Are you kidding me? 1 minus sine squared. That's supposed to say sine squared up there. 1 minus sine squared is cosine squared. That's the very first thing on your identity page. All right, so that's cosine squared, over cosine x. Those cancel. How many times does 1 cosine go into cosine squared? 1 cosine. There it is. You made it. Remember, the answer on your test is the work. Okay, you got to prove how you got there. So show every step, and you'll get there. All right, let's look at 12. 12 looks even more fun. All right, I'm taking the left-hand side. Now, think about what this says. That's cosine subtraction. Cosine x minus y. Look at your formula page, and it says cosine x minus y. It tells you exactly what to do. Cosine x minus y is cosine x, cosine y, plus sine x, sine y. And all that is over cosine x, sine y, which that really, when first looking at it, it's like, that doesn't look that close to tangent. Here's what we're trying to get to. Always remember, what am I trying to get? I'm trying to get tangent and cotangent. So let's do this. Whenever you have one term, this is a little trick. Anytime you have one term in your denominator, you can take that fraction and break it up into two pieces. So I'm going to do cosine x, cosine y, that first term, and put it over the cosine x, sine y. Then I'm going to take the second term on the top, the sine x, sine y, and put it over to cosine x. And guys, I cannot sit here and tell you exactly why I knew to do that. I just know I'm trying to get I see two terms over here that are added up. So I had to break this one term, this one big fraction, into two pieces down here. And when I do that, look what happens. Those cosines cancel. Over here, those sines cancel. And look what that gives me. It leaves me cosine over sine. By the way, that's cotangent. I about wrote that backwards. That's cotangent y. And if you look right here, look what's left. Sine x over cosine x. That's tangent x. Look what this said. My handwriting tonight? Oh my gosh. Look at this and look at that. We made it. Okay? Not that huge of a deal. Or maybe it is. I don't know. Okay, 13. 13 says find f of g of x and then a domain. Don't forget the domain here. F of g, so I'm going to take function g, plug it in there. If I do that, it looks like this. It looks like x squared plus 3 minus 3. Obviously, the 3's would cancel. I would get square root of x squared, which is just x. Okay, so that's f of g. That's the first part. The domain, the way you do domain for composites is you do the domain of the second one, of the g. So I'm looking right here. The domain of that g, because there's no fraction and there's no radical, is all reals. Then you compare that to your final answer here, which is also all reals because there's no fraction and no radical. So because they're both all reals, the domain for the whole thing is all reals. Let's go 14. Got two more. 14, find g of negative 2. So to find g of negative 2 here, you just got to figure out where you're going to plug that in. I think y'all are great at this. Negative 2 is less than 1, so I'm going to plug the negative 2 right there. Negative 2 plus 4 is positive 2. That's all you do there. G of 1. 1 equals 1, so I'm going to use the same one again. 1 plus 4 is 5. Then it says find g of 5. 5 is bigger than 1. 8 minus 5 is 3. So there's your three answers there for 14. I think you'll do fine on that one. Number 15, tell algebraically whether it's symmetric to the x, the y, or the origin. Okay, to find x-axis symmetry, it's backwards what you think. You're going to plug in a negative y. Okay, so plug in a negative y, and then work it out and see if you get the same thing. If I plug in a negative y, I get this. That's not the same thing as I started with, and it's not the direct opposite. So there's no x. X did not work. X did not work. Did not work. To try the y, I'm going to plug in a negative x. If I do that, I get this. Gives me a negative 3x minus 2y equals 3. So I look back up here. Is that the exact same thing or the exact opposite? Nope, it's neither. So y did not work. So to find the origin, you got to plug in a negative x and a negative y. And see what happens. I would get a negative 3x and a negative 2y. Sorry, it's a negative y. Positive 2y and equals 3. So I'm looking at that thinking, is this exactly the same thing as this? No. Is it the exact opposite? Almost. What messes it up is the 3. The x and y are exact opposites, but the 3 is not. So that means the origin did not work. Okay, so no symmetry whatsoever. But that's how you do the symmetry. All right. Hope that helps. Obviously, you can go back and look at whatever you need to. Please come see me tomorrow if you need some help, or if you're watching this on Friday, come see me today before your test. Love to help you, help get you ready. Last test before Christmas, finish strong, and I'll see you.